Here we're going to talk about side splitter theorem, which is an easier way to solve for a variable in a triangle if you know that two segments are parallel. Then you can compare the ratios and know that they're congruent. So if you have parallel lines, RS, XY, therefore RX and QR is going to be the same as YS SQ. So, side splitter theorem. So, first thing we want to know, do we have parallel? Yes, we do. We have parallel. Therefore, we know that we can compare 12 over x plus 1, 9 over x. No longer do you have to do 12 over x plus 13 equals 9 over 9 plus x. So it's a shorter way only because we have parallel lines. So when you cross multiply, it's 12x equals 9x plus 9, and then therefore we have 3x equals 9, x equals 3. So use parallel lines to your advantage. So what's the value of A? Same thing, same concept. You have parallel lines, so that's all you want to check. Do you have parallel? Yes, we do. Therefore, we're going to use the side splitter, what I like to call rule, theorem, which says A over A plus 4, 12 over 18. So, cross multiply, we have 18A equals 12A plus 48. So we have 6A equals 48. And then 48 divided by 6, we have 8. A equals 8. Now we have the corollary to side splitter theorem, which says if you have more than one parallel lines, then you can compare the ratios to each other, which are still going to be congruent. So AB compared to BC is the same ratio as WX, XY. So first thing you want to do we have parallel? Yes, we do. Then we want to apply the side splitter rule or side splitter theorem. So looking at this states that, okay, side A is 9. We don't know x is the same as 7.2 over 8, which is the same as whatever y is over 6.4. So now we can solve. So if we're going to solve, we have 9 over x equals 7.2 over 8, cross multiply. We have 9 times 8 and divide that by 7.2 and get 10. So x equals 10 yards. Now you have 7.2 over 8 equals y over 6.4. So you have 6.4 times 7.2, divide that by 8, and you get 5.76 yards. So that's using the corollary to the side splitter theorem. Just comparing the ratios, setting up a proportion, cross multiplying, and solving for a variable. Which leads us to the triangle angle bisector theorem, which says if you have an angle bisector, then the angle bisector, the segment divides the opposite sides into two segments that are going to be proportional to the two other sides. So we're comparing those two, AC and CD, to DB to AB. Not saying that they're congruent, I'm just indicating which ones you're comparing to. So CD, DB, CA, BA. Which is the same as BA over DB, CA over CD. Again, same thing. Next, let's actually apply it. So first thing we want to do we have an angle bisector? Yes, we do, so we can use the triangle angle bisector rule, theorem. So what does that say? We say we have 10 getting compared to 18, therefore 12 getting compared to x. So we have 10x equals 12 times 18, 216, divide by 10, which is x equals 21.6. So, do we have an angle bisector? Yes, we do. We have an angle bisector right there, therefore we can apply to now triangle angle bisector theorem. So we have 9.6 over 16, y over 24. So we have 9.6 times 24 equals 16y. Therefore, y equals 9.6 times 24. Divide that by 16, and you get 14.4. So there we go. Triangle angle bisector theorem. Use it when you have an angle bisector. Corollary to side splitter theorem. Use this when you have two or more parallel lines. And the side splitter theorem. Use it when you have a triangle and parallel lines, or in this case parallel segments. If you have any questions, shoot me an email. See me before school or after school.